Chapter 8.2 Ellipses. This will correspond with Learning Target 9.2. We'll be learning about the geometry of an ellipse, translations of ellipses, we'll look briefly at orbits and eccentricity, and in class we'll talk about the reflective property of ellipse. And then with the eccentricity, we'll look at why ellipses are the paths of planets and comets around the sun or of moons around planets. An ellipse is a set of all points in a plane whose distance from two fixed points in a plane have a constant sum. The fixed points are the foci, which is plural of focus, of the ellipse. The line through the foci is the focal axis. The point on the focal axis midway between the foci is the center, and the points where the ellipse intersects its axis are the vertices of the ellipse. That's a lot of words. We're going to break it down and look at each one at a time. Let's start with the definition of an ellipse. How to draw an ellipse. If we take two push pins and put them in a piece of paper and a piece of string in a loop through those push pins and a pencil going through that string, that pencil, when it goes around the foci, will draw an ellipse. And that's the basic definition of an ellipse, that these two sums, this total length of string here, doesn't change. The individual side lengths of this triangle can change, but when you add them together, that amount doesn't change. And that's how you get an ellipse. So here are the different points. We have our foci here. Those are our push pins. The furthest out that we get are the two vertices. Halfway between the two vertices and halfway between the two foci, we get the center. All of those lie along the focal axis. So here are our equations. This is our toolbox for ellipses. This is ellipses with a center at 0, 0. Our standard equation is x squared over a squared plus y squared over b squared is equal to 1. This is an equation for the focal axis being on the x-axis. The x squared will be over the a squared. The y squared over the b squared. The a squared will be larger. The equation is always equal to 1 for an ellipse. On the x-axis, remember, that's y is equal to 0. The foci will be plus and minus c for the x value and 0. This is the distance to the foci. Well, where does that come from? We have our a and we have our b. What about the c? That's the distance of the foci. So if you're given the foci, it's easy. But if we're not given the foci and all we have is the a and the b, we have a Pythagorean relationship here. A squared is equal to b squared plus c squared. Now this is different from the Pythagorean relationship that we've been studying since geometry, where we always look at a squared plus b squared equals c squared. Now we have to look at it alphabetically. It's still the two legs squared equal to the hypotenuse. We're just renaming them. The vertices will be plus and minus a. So it's the square root of what's underneath the x for the x value. And remember, our center is 0, 0. So the y value will be 0. The vertices are moving along the x-axis. The semi-major axis, that means half of the longer axis. The longer axis will be twice this. The semi-major axis is A. The semi-minor axis, half of the smaller axis, is B. And here's our Pythagorean relation. A squared equals b squared plus c squared. Think alphabetical order. If we have our ellipse going up and down, we get y squared over a squared plus x squared over b squared equals 1. The y-axis will be the longer one. So the focal axis is going along the y-axis, where x is equal to 0. The foci x stays equal to 0, and the foci will be plus and minus c for the y value. The vertices will be plus and minus a for the y value. The semi-major axis will still be a, although this time it corresponds to the y. The semi-minor axis will still be b, this time it corresponds with the x, and we have the same Pythagorean relation. So now we're going to use it. Find the vertices and the foci of the ellipse. 9x squared plus 4y squared is equal to 36. For an ellipse, an equation of the ellipse, it always needs to be equal to 1. So the first thing we're going to need to do is divide by 36. So we get 9x squared divided by 36. 9 over 36 reduces to x squared over 4. 4y squared over 36 reduces to y squared over 9. And this is our 36 divided by 36, or 1. Since the larger number is the denominator of the y squared, the focal axis is the y-axis. So a squared will be 9, b squared is 4, and c squared will be equal to a squared minus b squared, or 5. So from this, the vertices will be 0, plus and minus 3, and the foci are 0 and plus and minus the square root of 5. C squared was 5, so c is the square root of 5. Try this. Find the vertices and the foci of the ellipse. 7x squared plus 7y squared is equal to 77. First thing you want to do is set it equal to 0, so divide through by 77. Pause the video and work this one out. Now we want to find the equation of an ellipse. If we're given the foci and the minor axis in this case, we can set it up to be an equation. So we have foci at -2, 0 and 2, 0. So the first thing you want to do is to draw a picture. So you'll see what it looks like. So we see that the center is 0, 0, and the foci will be on the x-axis, and the distance from 0, 0 to both foci is 2. So c is equal to 2. The semi-minor axis is b. The minor axis is 2. Half of that is 1. So b is equal to 1. So now we have b and we have c. Remember, a squared is equal to b squared plus c squared. A squared equals 1 squared plus 2 squared, which is 1 plus 4, or 5. So the equation of the ellipse is x squared over a squared, x squared over 5, y squared over b squared is 1 squared is 1, is equal to 1. Try this one. Find the equation of the ellipse with foci at 0, 3 and 0, -3, and the major axis length is 10. First thing you want to do is draw a sketch and find the semi-major axis. Pause the video and work that out.